When we think of places in our solar system that might harbor life, our minds usually go to Mars, the red planet. But there's another world, far more intriguing, far more alien, and possibly far more promising. It's a moon of Jupiter, named Europa. Slightly smaller than our own moon, Europa is covered in a shell of ice, crisscrossed with reddish-brown streaks, and it hides something beneath that frozen crust that has captivated scientists for decades. Europa is strange. Its surface is one of the smoothest in the solar system, with almost no impact craters, suggesting that it is geologically active. Its icy plains are fractured and rearranged, as if something beneath is constantly moving and reshaping the landscape. And that something might be a global ocean of liquid water, containing more water than all of Earth's oceans combined. Today, we're going to explore why Europa is considered the strangest object in the solar system, what lies beneath its ice, and why it has become the #1 target in our search for life beyond Earth. A surface that shouldn't look like that. Let's start with the surface. Europa is covered in water ice. But unlike the ice on Earth's polar caps, Europa's ice is not static. Images from the Galileo spacecraft, which orbited Jupiter in the 1990s and early 2000s, revealed a surface that looks like a cracked eggshell. There are long, linear ridges, chaotic terrain where blocks of ice seem to have shifted and refrozen, and vast areas that are nearly crater-free. The lack of craters is a huge clue. A surface that old, in a region of the solar system bombarded by comets and asteroids, should be pockmarked. But Europa's surface is young, perhaps only 20 to 100 million years old. That means something is constantly resurfacing it. The most likely explanation is that liquid water from below periodically wells up, freezes, and smooths over the scars of impacts. In other words, Europa's ice shell is floating on a hidden ocean, and that ocean is active. More water than Earth. So, what do we know about this hidden ocean? It's not just a guess. Scientists have strong evidence. Europa has a magnetic field that shifts as Jupiter's powerful magnetic field sweeps past it. The only way to explain that fluctuation is a layer of electrically conductive fluid beneath the surface, salty, liquid water. Gravity measurements also suggest that Europa has a thick layer of liquid water, estimated to be 60 to 150 kilometers deep, sitting on top of a rocky seafloor. For comparison, the deepest point on Earth, the Mariana Trench, is about 11 kilometers deep. Europa's ocean could be 10 times that. And because Europa is tidally heated by Jupiter's immense gravity, the ocean remains liquid despite surface temperatures of minus 160 degrees Celsius or minus 260 degrees Fahrenheit. The total volume of water on Europa is thought to be 2 to 3 times the volume of all of Earth's oceans. That's a lot of water. And where there's liquid water, energy, and the right chemistry, life might have a chance. The engine of Europa. Why is Europa not a frozen solid ball? The answer is Jupiter. Europa orbits Jupiter in a slightly elliptical path, and the gravitational pull from Jupiter, along with its sibling moons Io and Ganymede, flexes and squeezes Europa with every orbit. This constant flexing generates heat inside the moon, a process called tidal heating. It's the same process that makes Io, the innermost Galilean moon, the most volcanically active body in the solar system. On Europa, tidal heating is not extreme enough to create volcanoes, but it's enough to keep water liquid beneath the ice. And it does something else. It likely drives hydrothermal vents on the ocean floor. On Earth, hydrothermal vents are oases of life, teeming with organisms that thrive on chemical energy rather than sunlight. If Europa has similar vents, they could provide the energy and nutrients necessary for life to exist in a dark, ice-covered ocean. Clues to chemistry. One of Europa's most distinctive features is its reddish-brown streaks crisscrossing the ice. For years, scientists debated what these streaks are made of. The leading theory now is that they are a mixture of salts and sulfur compounds, possibly brought up from the ocean below. The color suggests the presence of hydrated salts, like magnesium sulfate or sodium chloride, that have been irradiated by Jupiter's intense radiation belts. In other words, the streaks might be direct evidence of ocean material reaching the surface. If we could sample those streaks, we might find organic compounds or even microbial life frozen in the ice. The radiation at Europa's surface is brutal. It would sterilize the top few centimeters. But if the ocean is actively resurfacing, fresh material could be brought up regularly, preserving a record of what lies beneath. A window into the ocean. In recent years, Europa surprised us again. Scientists using the Hubble Space Telescope and reanalyzing Galileo data found evidence of water vapor plumes erupting from the surface, similar to the plumes on Saturn's moon Enceladus. These plumes shoot up to 200 kilometers above the surface, and they appear to come from the region where the ice is thinnest. If these plumes are real, and we're still confirming, they offer an extraordinary opportunity. Instead of having to drill through kilometers of ice to sample the ocean, a spacecraft could simply fly through the plumes and analyze the water directly. That's exactly what NASA's upcoming Europa Clipper mission plans to do. It will fly by Europa dozens of times, passing through the plumes if they exist, and sniffing the water for signs of organic molecules, amino acids, and other biosignatures. Radiation and ice. Of course, studying Europa is incredibly difficult. The moon orbits inside Jupiter's radiation belts, which are intense. A human could not survive on Europa's surface for more than a few hours without extreme shielding. Even spacecraft must be heavily protected. The Europa Clipper mission, scheduled to launch in the 2020s, will not orbit Europa directly. It will orbit Jupiter and perform flybys to minimize radiation exposure. And then there's the ice. If we ever want to actually explore the ocean directly, we'll need a cryobot, a probe that can melt through tens of kilometers of ice. That technology is still in development, but the scientific payoff would be immense. If we find life in Europa's ocean, it would be the most profound discovery in human history. It would tell us that life is not a rare accident, but a common outcome of planetary evolution. Could there be life? So, let's assess the case for life on Europa. You need 3 things: liquid water, a source of energy, and the right chemical ingredients. Europa has liquid water, an ocean larger than all of Earth's. It has energy, tidal heating, and likely hydrothermal vents. And it has chemistry. The surface contains salts, sulfur, and possibly organic compounds delivered by comets or produced internally. What it lacks is sunlight. Any life on Europa would have to be chemosynthetic, like the life around Earth's deep-sea vents. It would not be plants or animals we recognize, but microbial life, or perhaps more complex organisms adapted to the dark. We don't know if life actually emerged there, but we do know that Europa has had all the necessary conditions for billions of years. And given that life appeared on Earth almost as soon as conditions allowed, the odds seem promising. The Europa Clipper mission will give us our best chance yet to find biosignatures, molecules that indicate life, without ever drilling into the ocean. And if we find them, it will reshape our understanding of life in the universe. Why Europa matters. Europa is strange. It's a world where the ice is alive with motion, where an ocean deeper than any on Earth hides beneath a frozen crust, where plumes of water vapor erupt into the vacuum of space. But its strangeness is precisely what makes it so important. It represents the possibility that life might not require a planet in the habitable zone of a star. It might exist in the dark oceans of a moon orbiting a giant planet. If we find life on Europa, it would likely be an independent origin from life on Earth. That would mean the universe is teeming with life, just waiting to be discovered. And if we don't find it, that too would tell us something profound about the rarity of life. Either way, Europa is the strangest object in the solar system, and it holds the key to one of the biggest questions we've ever asked. What do you think? Should we drill through Europa's ice to find out what's down there? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.